Hey, what's going on, guys? In this video, we're going to cover one of my favorite data types in Python, the humble list. The Python list is the first collection type that we're going to look at. I'll explain what that means in a second. Others that we'll cover later are dictionaries, tuples, and sets. What is a collection type? Well, it's the first type that we're seeing that is made up of other objects. So we've already covered the string type, for example, which you can see here. And that string is just itself. It doesn't reference anything else. A string is itself. Likewise, a number is itself, regardless of whether that's a float or an integer or whatever. Lists are made up of other objects. In this case, you can see that this list is composed of some strings. So it's a collection of other things. So what might you use a list for? Well, if you're writing a small command line video game, which I highly recommend you do, maybe we'll even do that together, you might use that list to represent a character's inventory in your game. And that actually brings us to a lot of the features that lists have in Python. First off, they're dynamic. That means they can grow and shrink. A list can grow, for example, when your character picks up an item that you find in the game world, well, that item can be added onto that list. So it's not just what you define, but it's something that can grow dynamically while your program runs. Likewise, it can shrink. For example, if you drop or use an item that your character has, you can actually remove that from the list that represents that character's inventory. Now, that's just one use of a list. Obviously, they're used for all kinds of stuff. In Python, it's a real workhorse data type. So what can a list contain? We've already covered that it's a collection type, which is kind of composed of other objects. So what kind of other things can a list contain? Well, everything we've covered so far and all the data types that we haven't covered so far. So strings you know about, numbers you know about, and of course you can also use other lists. So a list can contain another list as one of its elements, and even that list can contain another list, on and on and on in the great circle of inception until your mind explodes. Let's start at the very beginning, defining lists. So you can open up your REPL and just start copy and pasting here. So books to read is this variable I'm defining. It's underscore separated lowercase words, just how the Python community likes it. And then there's the equals, which signifies that we're assigning to a variable. And here is the list literal right here. So it's this square bracket syntax. Inside of these square brackets are the actual objects that are in this list. In our case here, it's just 3 strings. Each object, each list item, is separated by a comma. That's the really important part. And a space, which is optional, but if you don't want the community to beat you up in a hasty nerd rage, I really recommend that you just add spaces after all of your commas that separate list items. Nice and straightforward, right? Open your square bracket, an object, separate it, another object, separate it with another comma and space, and then at the end, you've got your square bracket to close it off. If I now inspect this variable in my REPL, you can see that that's how it's printed back to me as well. So even if you had omitted these spaces, this is how Python kind of represents the list as a string. You'll see it printed out with a space. The other way to define these is on multiple lines. If you've got some instructions that you want to model as a list, you can absolutely do that. And in this case, you can see that because this is too long for one line, we don't want this to be like a mile-long line, although that's certainly possible. We want this to stay as readable as possible. That's always the main goal in Python. Here we again define a variable and give it this list literal, so just this instance of a list here with these square brackets. And what you can see is after the first line, I've tabbed over 1. Now you're not going to get errors if you don't do this. This or this is valid as well, but it's just not as readable. So you open it, you put the first element, you put a comma, and then on the next line you tab over from where that block of data started. So this starts with this variable, so we're just going to go over 1 tab and then continue and end each line with a comma. It is valid to not have a comma on the last list item, but I recommend you don't do that, because when you start getting into quickly copy and pasting things or adding list items, this can become a huge pain in the butt when you realize that after you shift some things around, an item in the middle doesn't have a comma, and that obviously is an error because you need right up until the last element a comma after each list item. So Put a comma on each line, including the last one, even though it's not strictly necessary. So now you can copy and paste this over as well. And you can see that Python allows you to do that, and it doesn't really care about what the spaces look like here. And now if we type out instructions, you can see that this is represented without all the nice formatting that we did here to make it readable for other humans. It just gives us the entire list in one big chunk and wraps it at the end of the line. So let's go ahead and look at this books to read item here. We access list items with this square bracket notation. So it's the variable that refers to the list or the list itself, and then the element that you want to access. So let's go ahead and get the first item here. Are you ready? We're going to expect Cryptonomicon. So let's go get that. And that is not Cryptonomicon. It is also a great book, but it's not really what we wanted. So what is happening here? The answer is to understand how to access these elements, you have to know how Python counts them. Indexing is the name for that. Indexes refer to the positions that list items are in, and Python, along with almost all other programming languages, starts counting at 0. So when we want the first element, that's actually the 0th index. Let me go ahead and quickly explain how that works. But just to show you, if I actually wanted the first element, I have to say, please give me the 0th element in books to read. So let's quickly back up and I'll talk about indexing. If we have this list here, you can see there's no variable referencing it. It's just a list literal. The first element here is indexed with 0. So the position is 0, but it's the first element, right? Element 1. The 1th index is the second element. The third element is the 2th index, and so on. Does that make sense? Even though we humans start counting 1, 2, 3, 4, Python starts counting 0, 1, 2, 3. List elements are indexed a second way as well, just to make them convenient for the programmer. Because you don't always know how long a list is, because these things can grow and shrink, there has to be an easy way of getting the last item, and there is. Indexing is done from the beginning and from the end. So the -1th element will always reference the last element. And you can basically start counting that way again. Just keep subtracting. So the -1th is the last element. The -2th is the penultimate element, so the one before last, and so on until you get back to the first. I just want to show you that this works the same way as when I have a variable reference to this list. If I get the 0 index, so the first element on this list, it is going to give me 1, just the way I expect. Likewise, from the end, we can count with -1. That should give me 4, because that's the last element. And then the one before last, 3, and the one before that, and so on. So I'm going to paste instructions into my REPL again, and we're just going to play around with instructions a little bit. You can see that I'm creating these variable references here. First is going to reference the first element, the 0th index. The second is going to reference the 1th index, and then we're going to also grab last and penultimate, which are just grabbing elements from the end. So I can just cleanly copy and paste this over and inspect what I've got, just to make sure. So penultimate should be order pizza. First should be buy Deus Ex, and that really should always be the first thing that you do. If I want to print something, if I want to print all of these out, I can do that. And you can see that with no formatting or anything more than just a space separating each element, I can pass these to print in a comma separated way, and print will go ahead and just concatenate all of these things together. So it'll look up first, it will look up second, last, and penultimate, and then just concatenate them all together here. Okay, so you've seen that you can grab indexes from a list literal, the way I'm doing here, or you can grab them from a variable that points to a list. You can do that too, like in books to read, in that case. Let's just quickly talk about the last thing I want to say about indirection when working with these things. If we have instructions 5, which is order pizza, how is it that we always come back to order pizza? Story of my life. I can reference this with a variable and then work with it. So then I can say story of my life lower you can see that's order pizza lower, and then I can maybe do like create a string with that and print I want to plus story of my life lower. And so that should give me I want to order pizza. And I do. I really do. However, there's no need to go through all this indirection unless it helps readability. So for short kind of one-liners like this, you can totally work with the reference directly. I'm going to go ahead and get the 5th index, so that would be the 6th element, and work with it directly in there while I make this string. And that comes out to the same thing. Does that make sense? 0, 1, 2, 3, 4, 5. Let's talk about common methods for talking to lists, getting lists to do stuff for you. So like other Python objects, lists have certain messages that you can send them that they understand how to work with. You remember this for a string. Just as an example, we have the lower method, and the way that we send this message lower to a string, this object, is with the dot notation. Now we're going to get much deeper into this and how this works. It has to do with classes, and there's words like functions and methods that you're going to learn. But for now, basically we can just think of these as messages that are being sent between objects, and that's really how all of this came to be. All of like object-oriented programming was originally kind of designed as this messaging between objects in your program. And I think it's good to start with that mindset and then look at these modern implementations of it, like we have in Python, for example. So we want to send messages to a list. Lists can read out certain messages if you know the right ones and do useful things as a result. The things we want a list to do, just as an example, things like grow the list by appending something to it. So instructions currently, you can check its length by using the len function and putting the instructions object inside there. And you can see that we have a length of 7. If we want to grow that by one item at a time, we can use this append method. Now the append method is really just a function that every list understands. Every list knows how to append, so this is a message we can send. Instructions is our list, you see it here. We're going to tell it to append another item, and that's just a string, you're welcome. So let's go ahead and do that. Instructions, append, you're welcome. Now nothing was returned. We're going to presume that everything went fine, and let's just inspect the length of our instructions object. You can see that's now grown to 8. And if I inspect my instructions object again, the list that instructions references, you can see that your welcome has been added to the end. Now that previous thing is still there, we haven't replaced it, but we have appended a single item. If you want to append more than one item at a time, you can use the extend method. So every list understands extend using this dot notation, and that's a function, as you can see with these parens, and you feed that a list that you want to extend the original list with. So if I want to add hi and there, 2 strings, to the end of this, I can do that with extend hi there. Now don't forget this list syntax. We're actually feeding this function a list. I know this is starting to look a little complicated, but that's all it's doing. You can always reduce whatever program you see down in your head to small, understandable chunks. And that's kind of the whole idea behind programming and abstraction. Maybe the most important idea that we've invented ever. So if I call this extend function and I pass it another list, then I'm going to extend this first list with this second list. Let's take a look at what that looks like. So now instructions has grown again by 2, and you can see that hi and there have been added to the very end of the list, and just because it's getting kind of long, we can inspect the length again and see that it's grown by 2. There is another way to extend lists with this plus equals syntax. It's very convenient because it mirrors the syntax that you use to extend a string with a second string. So you've seen that before, but I actually don't recommend using it. The performance is noticeably worse. It behaves strangely with scoping, which we'll talk about later. So I want you to know that this is there, but using this extend method is much better for when you want to add multiple items. Let's talk about replacing an element. You've got an element here, for example, this there, but you actually don't want it to be there. You want to replace this, so destroy what's here and replace it with something else. So why don't we take the last element and replace it with wonder why you haven't played this yet. The way we do that is by referencing the list, either as a literal or with a variable, the way we're doing here. The same bracket syntax. So if I just did this, it would just print the last element for me. Actually, let me show you that. But if I then add an equals, what Python hears is, oh, at this last element, don't give it back to me, but assign something new there, put a new value there. So when I do that, there is replaced with wonder why you haven't played this yet. And now when I go ahead and see what's there, I get wonder why you haven't played this yet. And most importantly, it has destroyed the value that was in memory originally here. So it's not hi, there, wonder why you haven't played this yet. The there has been totally replaced. Okay, so this is the copy paste over something else of working with lists. So just remember that this is destructive. If I paste this value at line 60 here, so instruction 0 equals, this replaces the 0th element, then by Deus Ex will be utterly destroyed, and we wouldn't want to do that. The way to insert an element at a certain position without destroying anything is the insert method. So it's insert, and then it takes the index, the position at which you want to add something, and then the thing that you want to add. I'm just using strings here because they're the easiest to understand, but again, it can be any Python object. So let's do that. Instructions insert at position 0, so at index 0, first calm thyself. And what Python is going to do, I'll show you the new list so you can compare it. Python goes in, finds the 0th index, so the first element, shifts it over and everything after it, and then sticks something new there, whichever thing you told it to stick there. Does that make sense? So it goes in, it kind of burrows to the index you give it here, so 0. It goes, all right, I'm going to go just before that, and I'm going to make some room, blam, and then it makes some room, and then it adds this element, and it shifts everything else over. So the 0th element here has become the first element, so this has now been shifted over, and everything after that gets shifted too. So this is a way of kind of burrowing in there and adding something at a position without destroying anything. That's the important thing. It's non-destructive. Speaking of destruction, let's talk about the del keyword. We've got a bunch of junk here at the end that we can just go ahead and get rid of. For example, you're welcome, hi, wonder why I haven't played this yet. It's all very charming, but we can go ahead and get rid of it. The del keyword lets me do that. It's a little bit strange. There's no, it's not a function the way you might expect, so there's no brackets here. It's just del space and then the reference to the index that you want to remove. -1, as you remember, is the last element. So you can see that wonder why you haven't played this yet is gone now. And if I keep doing that, -1 is always updated. Every time that list changes, it will always point to the last item. So if I delete the last item twice, that's the same as deleting the last 2 items. And if I do it 3 times, that's the same as deleting the last 3. I can see that I'm basically back to the original list, except for this inserted item at index 0. So now you know how to delete destructively an object at a certain index. We've been dealing with indexes a lot, and that is certainly useful. You definitely have to know how indexes work, and they have to kind of start becoming intuitive to you, this whole counting from 0 thing, or counting from the end with -1, and so on. But a lot of the time, you're not going to know how long something is or what index specifically something is at, although you can find that out. Removing elements by value is going to become important. So let's append remove me. And just to demonstrate how this works, I'm actually going to insert this as well. So this object will be in here twice, this string. We'll say index 3. We will insert remove me as well. So now instructions looks like this. 0, 1, 2, 3. So the 4th element here is remove me. And then we've also appended it to the very end. So append has added it here. So first we appended, and then we inserted at element 3, 0, 1, 2, 3. So now we've got remove me in here twice. So let's see what happens when we remove. This remove method will go and look up the value that you've got. It will give you an error if what you're trying to remove isn't there. We'll look at that in the errors video. But instructions remove me, we'll go ahead and find, can you tell? the first occurrence of the value you've given it, and then go ahead and remove that from the list. You can see the second occurrence was untouched. This is not greedy. This is how you would describe it, right? If it were greedy, quote unquote, it would go through and remove every single occurrence of remove me, this string, but it doesn't do that. It goes until it gets a match the first time, removes that, and then exits. Then it returns and says, yep, I went ahead and removed this value. What it's really saying is I removed this value once, because I can go ahead and remove it again. There's still that last element. Does that make sense? So remove removes the first occurrence of the value that you give it. If that value doesn't exist in there, it gives you an error. Let's talk about List.pop. Pop is a list method, and it can take an argument, but you don't have to give it an argument. So you can see you could say pop3, or you could just say pop. By default, if you don't feed it anything, it will take the last, the -1th element from a list. It will remove that and then return it to you. So if I wanted to pop the last item here, close the curtains and turn off the lights, I could just say instructions, pop, and then hit enter. That value has now been popped and returned. It is gone. How many ways can I misspell instructions in one video? Stay tuned to find out. So instructions now has had the last item removed, and because I didn't reference this with anything, I've now basically lost the reference to this value, close the curtains and turn off the lights. And Python can actually go garbage collect this, so that memory can actually be overwritten, reclaimed, zeroed, whatever. I have no guarantees about this because I'm not referencing this with a variable. So if you want to pop something off the end of the list and then work with it, what you actually want to be doing is story of my life equals instructions pop, because somehow magically we've ended up with order pizza again. How do we always end up at order pizza? What is the universe trying to tell me, man? It's rough. It hurts my feelings a little bit. Anyway, so we've ended up at order pizza again, even though the instructions list no longer contains it. Because pop has returned it out, I'm able to reference that with a variable. Instructions pop will return something out, but it's up to you to actually hang on to that thing. Otherwise, it's gone forever if you don't use it. So you want to use it, go ahead and reference it. If you liked it, you should have put a reference on it. I'm so sorry. I'm so sorry. I'm tired. I love you guys. Forgive me. So I just want to show you, you can also pop a different index. Yeah, you can do that. I don't use that a lot. It's like either I'm popping from the end or from the beginning, so 0, depending on if it's a stack or a queue that I'm trying to model. It's rare to use other indexes, at least for me, but I want you to know that you can do that. There are some other methods that I feel like this video is getting long enough and there's enough material in here to kind of blow your mind for a little while and give you something to work with or work on. There are more methods that lists understand. I would look at the .index method. The sorted function is interesting. List.sort, also interesting. I would recommend that you look at the official Python docs for that and just familiarize yourself with some other list goodies. That's your start. You know how to add things, you know how to remove things, appending, extending a list with multiple items, deleting, replacing, inserting things. I already said inserting, but I'm so excited about it that I'm going to say it again. You know basically why you would use a list, what kinds of things you would model with a list, like inventories, lists of things that you're going to work off later. For example, a web crawler, keeping track of URLs that it hasn't crawled yet. Lists are kind of like the workhorse of a lot of the programs you're going to write. And Python has cleverly designed them to be incredibly powerful and to be very easy to use. For now, just practice what you've seen here. If this has been helpful, please share it, like it, comment with any questions or problems that you had, anything that was unclear, and I'll see you guys in the next video.